Well, welcome everyone to the first Edmonton Pastime session of 2025. To kick it off, we have Chris Hyde from.
From Albuquerque, New Mexico.
Oh, excellent. Albuquerque, New Mexico, talking about data and fabric. And without any further ado, I'll pass it over to you.
Great. Thank you very much. Thank you all for having me today. As far as any questions, we're a pretty small group, so just go ahead and chime in. If you're joining online, go ahead and take yourself off mute and just ask the question. If you can, that should work pretty well. I've only got one screen set up, so I can't really monitor the chat as well. So Brent, Wilson, if you all could, watch the chat, let me know if there's a question that comes up in there. Just jump in.
Will do.
All right, so this is me. I am Chris Hyde. My pronouns are he, him. And I'm a Microsoft Data Platform MVP from Albuquerque. I also run the data platform group there. So we have meetings really about every other month at this point. So just look for us on Meetup and jump in. We take anyone remotely as well. Most important bit on here though is down at the bottom right. If you like the session, get on Blue Sky, tell everyone how good the session is. If you don't like the session, well, that's what the email's for. Just send me a note. Let me know what I could do better next time or what you wanted to see that you didn't get to see this time. All right, so here's what we're going to talk about today. This is going to be a very 100 level overview of Fabric. It's not a deep dive at all. I heard that there were a couple of people in the community up there that were really looking for, a very simple entry point. So if you all have watched all the Guy in the Cube videos, or we've been through a bunch of Microsoft Learn modules, this might not be the session for you. But if you have just kind of heard buzz about Microsoft Fabric, you keep hearing the word fabric, and you don't really know what it's about yet, then this is the perfect session.
That's excellent. I keep hearing fabric and even Lakehouse, which doesn't involve fishing. So
Well, hopefully we should straighten some things out today.
Excellent.
Because we are going to talk about Lakehouse architecture. And Fabric is built on Microsoft's version of Lakehouse architecture called OneLake. We'll talk about what that means. I'm going to go through a bunch of the different components of Fabric. Fabric is just huge. So we'll do some demos, but we're not going to be able to do demos on every single component in there. So we'll do some of the simpler pieces, and then I'll kind of tell you where to go to see things like the machine learning or the real-time intelligence. All right. So hopefully that should be a good base setting. All right. So what is Fabric? So it's easy to say it's Microsoft's next gen all-in-one data analytics product. That doesn't really help, right? What does help is kind of the next piece. So what they've done is they've integrated data warehousing, data engineering, and data science, all those tools that people are using, and they're putting them into the same portal as Power BI that a lot of people use today for reporting and data visualization. Power BI is very popular. And what they're trying to do is they're trying to put this suite of products together and package them as software as a service, or SaaS, rather than platform as a service, which is what we might be used to in the Azure analytics or data engineering world. So let's think about if we were trying to do an end-to-end solution on, say, Amazon. We're bringing data in. Maybe we're using Apache Airflow, I think, to coordinate that. And we're dumping it in an S3 bucket. And then we're using Databricks to do transformations. And we're loading it into Snowflake. And then on top of Snowflake, you've got Tableau or Click to do the visualizations. And that's like 5 or 6 different platforms that you have to have and subscribe to and connect all together to make sure everything is working. So what Microsoft wants to do, gotta be honest, in the Azure ecosystem until like last year, it was kind of the same way. You had all these different Microsoft clouds. You had to bolt them together. But Microsoft's idea now is to put all these things into one package. Sell it like a software bundle, not like individual platform pieces. Make sure that it's all connected already behind the scenes, and so that it should be much easier for people to use. The other thing that they want to do, I'm not really going to be able to see the results here, but put your hand up if you're in the room or if you're at home, if you're a BI person or data analytics person. Put your hand up and then leave it up if you spend like 80% of your time just moving data from one place to another. Right? So we've got a lot of us. The idea of OneLake is to have a central data lake. And once the data is in there, it stays there. And then all these other tools can just access it. Right? We don't need to keep moving the same data from place to place to place so all these different tools can get to it. All right. So one thing I did leave out here is this is a relatively new product. It has been generally available since November 23. So we're in about month 14 and 15 of this thing being live. So it's still a fairly new product. There's still a couple of gaps. There's still a couple of hiccups. That's okay. But if you think about where Power BI was when it was 14 months old, there were a lot of gaps there. And now Power BI is just this giant enterprise ready, really good reporting and visualization tool. So I encourage everyone to, I guess this is my sandbox moment, right? I'd encourage everyone who's in the analytics space, in the Microsoft platform, kind of get on board here, because this really is where they're going with analytics in the Microsoft data platform. So if you haven't had a chance yet, definitely check it out. They have, what's to use the cliche, all the different teams at Microsoft are kind of rowing in the same direction on this one. It's not like it's been in the past where maybe, a couple of the products were sort of competing with each other. They're all rowing in the same direction here. All right. So throughout this slide deck, I've got a few slides here from a guy named Christophe Manier, who works for Microsoft in France. And he's put together these really nice designs to sort of add a little extra. So maybe if you want to download this deck, I'll give you all a link at the end, and so I make sure you stay on and stay engaged. But there's a lot of these little slides sprinkled throughout here that you can go in and maybe you don't remember what I said about SaaS versus PaaS. You can come in here and you'll get a little refresher. All right, so this is their foundation. And you can see right in the middle, we've got this thing called OneLake. And at the top are all our different experiences or different tools. I think we usually call them tools, right? But Microsoft is really calling them experiences. You've got your Data Factory experience, which is moving data back and forth. This is the same as Azure Data Factory today, just an evolution thereof. You have Synapse data engineering. These are your Apache Spark tools, so your Python or Scala notebooks. And then Synapse data warehousing, which is a T-SQL based server. It's like Synapse serverless. In the today or recent past, you have Synapse data science, which is your machine learning, your ML Studio. And you have, I believe the real-time analytics is now been renamed real-time intelligence. That is your KQL, your custo based data. That is really your streaming data. Your just tons of data coming from your IoT, your Internet of Things devices. And then you've got, of course, Power BI as well. All right, so we see OneLake is right in the middle. So what is OneLake? So Microsoft wants this to be like their OneDrive for data. That's the marketing spiel. They want it to be as easy to get data into the OneLake data lake as it is for you to add a file to OneDrive business. So it's got full compatibility with Azure Data Lake Gen 2. It's got a great feature called shortcuts, which allow data virtualization across other ADLS Gen 2 lakes, across Amazon S3 buckets. And I think since I last did this deck, I've got the Google storage piece working together. So you create this shortcut, and all the engines point to it just as though it was in your OneLake. So really great feature there. Now all the data here is stored in what we well, I guess there's two ways to store data, right? There's like a regular data lake. You put a file in, you put a CSV in, it stays in the file format. But then you can turn that into a table. And the table is in Delta Parquet format. That allows all these different tools to operate. So one thing that does, that common format, that helps to ensure that all the different tools can access it. And it decouples the storage, where we're storing that Delta Parquet from the compute, which is all the different engines kind of attaching to it and manipulating the data. Right. So in the past, like think of our SQL Server, either on-prem or Azure SQL DB. You've got your SQL engine, you've got your MDF file, and you can't have one without the other. They just don't work without the other piece. Right? Here we've completely decoupled that. We've got the data always stored in Parquet, and all the engines can just spin up, access the data to do what they need, and then shut down. So you can't have one without the other. We've also got a great tool called the OneLake File Explorer that just allows people to drop the files in very simply. Works just like the OneDrive Explorer and Windows Explorer. So very familiar UI situation there. Again, here's one of Christoph's slides. I'm certainly not a good artist like this, but if you need to come back in and sort of refresh yourself later, it's in the deck for you. All right, so here's a little deeper dive into that slide we saw earlier. So what we see now is on OneLake, and we see these different data sets, and whether it's for a data warehouse or a Lakehouse or a Power BI data set. And this was, this image was created before those were renamed to semantic models. And our Custo real-time DB, it's all Delta Parquet image. And then we've got this layer OneSecurity above that. The idea is that we're setting one set of security principles and roles, all that stuff, and those permissions apply to the data no matter which engine is connected to it. So if you're using T-SQL and the Synapse Data Warehouse experience, or Spark from Lakehouse, or you're pointing your ML Studio at it, it's all going to go through the one layer of security. You don't have to set up separate security for each of those different tools or what would have been different platforms in the past. Okay, hand up?
Yeah. So with the security, is it based on the somehow on semantics, or do you have to say let's say you've brought in some CSV files of customers or something, along with everything else, and you've got your special customers you want to apply extra security to. Is it per object in the OneLake store, or is it at? Can you do it at a semantic layer of protecting phone numbers or shoe sizes or something?
So it is more of the first. Now you can build in some of the other techniques in specific columns.
Okay.
But sort of the default is kind of object security followed by role-based security that you can actually set up uh, to allow different different groups to see the different rows rather than your example is different columns,
Yeah.
right? Their plan is to you can do that, but their plan is to go by kind of row by row first, so you only see the rows that are appropriate to your group.
Okay. I'm sure there's multi-days worth of figuring out the security.
Yeah, the security could be an 8-hour pre-con very easily. All right, so I mentioned Parquet multiple times, so it may be due to a lot of you. So yeah, there's a lot of information here on Christoph's slide. So the simplest way that I could sort of think to explain it is think about a regular CSV file. Everything is stored in rows by row, just row by row by row. And what's that like in SQL Server? It's just like a table, like a regular row-based table. Parquet is like a column store table. So what it does, all the data is stored as columns. If data in there is duplicated, it basically is put in there one time and then a pointer to that data is stored. So it becomes, we get very, very good compression. We get probably a 1 in 6. Actually, I think for this demo, I'll see, we just drop in a simple CSV, turn it into a Parquet table, and we get a 6-to-1 compression without doing anything more than a few mouse clicks. And if you think about that over a big enterprise data warehouse and how much duplication of data in there you have, you can really save just a ton of space. And so what does the ton of space do? It cuts down on I/O, on the input output. So it really speeds up your I/O. So we get just insane performance over, terabytes and even petabytes of data. But it's all because Parquet, all that data under the hood is stored in column, stored in Parquet, and stored in column store.
Presumably, Parquet files are expensive to update.
They're a little bit expensive to update. Really, what happens, let's say I update a row in Parquet, I'm really soft deleting a row in a file and adding a new file with the extra row. And then there's a cleanup process that comes in behind to sort of lunch that together. So it is a little more expensive, but the read performance is just so good for all of our analytics purposes. It's not something that you wouldn't want to run a transactional system on Parquet. But any kind of analytics system, that's definitely what you want. So this idea is this idea that was building in the analytics community called Lakehouse. So Lakehouse, this is a direct quote by Databricks, who coined the term, that it's an open architecture that combines the best elements of data lakes and data warehouses. So data warehouses are great for structured data. Right? That's a technique that's tried and true. If you've got data that's in rows and columns, fantastic. But once you've got other types of data. You've got JSON data, you've got files, you've got images, data links. Like more flexible to handle it. So, what they've done, they've kind of, taken the best parts. So we've got 10 key features. We'll talk about those. And then we're going to talk about something called medallion architecture, which is the classic way of organizing these lake houses. So here are 10 key features. We wanted to have all the transactional support of an ACID compliant database system. Right? Data lakes historically are not. They do not have that support for transactions that a data warehouse does. But a Lakehouse, let's keep that ACID compliance. We want schema enforcement and governance. We want to be able to track when our table schemas change. Again, something we've always had in warehouse. Data lakes, not so much. You tend to put a new old thing in a data lake. That's how you end up with a data swamp. All right, so let's keep that feature from the warehouse. Now, let's make sure we can support multiple BI tools. Right? Data warehouses, quite a lot of times, just like with SQL, you're kind of locked into a specific tool. So let's support as many BI tools as possible. We've talked about having the storage being decoupled from our compute engines. We want to use open standards. So this, Parquet is not a Microsoft specific thing. This is a fully open standard. Any Parquet that is in your OneLake, any tool that can read Parquet can read that. Can read that file because it's an open standard. Right? We want to be able to support both structured and unstructured data. Unstructured data, like I said, the JSON blobs, the images, etc. And we want to support multiple types of analytics workloads. We want to have our reporting, our our machine learning, anything that's looking at our data. We want to make sure that that's available. We want to be able to support real-time streaming data easily. But we still want to make sure that we've got the traditional security and access control of the warehouse, and that we can govern the data, put data catalogs on it. So those are the kind of 10 key features that makes up the Lakehouse. Just the main idea is it's sort of the best of breed, the best of both worlds between data lake and data warehouse. Right. So one thing, we talked about needing the ACID compatibility. We have a level over the top of those Parquet files called Delta. And again, this is still an open standard. So the Delta layer, that gives us the transaction compatibility, it gives us the schema drift. And so some of the terminology gets a little confusing because Microsoft will say Delta Parquet, which isn't really a thing. Really, it's more true to say Parquet with a Delta layer. But it's all semantics. So you'll hear all sorts of stuff. But just keep in mind that all Delta, when they say Delta, all Delta is Parquet underneath, but not all Parquet files have that Delta layer on top. But if we're creating a table in a Lakehouse, yes, that table is going to have that Delta layer to make sure we've got the transactional support that we need. All right. And Databricks also came up with this idea of the medallion architecture. They've divided that up into bronze, silver, and gold. And a lot of us have worked on data lakes where we had kind of a war zone and a transform zone and then a fully curated zone. Or we've worked on we've had a staging layer and we have a final enterprise data warehouse. This is all semantics for the same thing, really. There's nothing new under the sun. So when they say the bronze layer, that's the equivalent of our staging. layer today. That's the raw data. It's untransformed, just as it comes in. Because some people, one client that I worked with, their machine learning people, their data scientists, they always wanted to go back to the raw data from the system. They wanted to, in some cases reinvent the wheel, but that was their priority. So they would always go to the bronze layer. A lot of times we're going to have a silver layer where we start doing simple transformations. We start cleansing the data. We start conforming data. How are we handling nulls in our data? How are we handling missing data? Right? Maybe we're keeping this in the same shape that it comes in from our business systems. Maybe this is still in their normal form. That's fine. We can write some simple reports against it. But ultimately, we want to get our data into our gold layer. We want it, fully transformed. We're probably going to put it in a star schema. So it's going to be dimensional rather than relational. We wanted, to have gone through the data governance process, so many calculations and transformations. They've been vetted by the system. So our gold layer is our ultimate reporting layer. Right? And here's the link if you want to go kind of further in deep about those. Follow this link. Dave Briggs has a lot of material about what's the difference between these layers. But just know that you'll hear about data moving through bronze, silver, and gold. All right, so that is kind of the base of Lakehouse. So let's jump over to Fabric and look at the first demo. Okay. Can everyone see the screen okay?
Yeah, looks good.
All right. So this is what happens when you jump into Fabric. Yes, you get to choose from all the different experiences we've talked about. There's a new one here, databases, that's just been announced. We haven't talked about this industry solutions piece is new as well. But these six here are the things that we've talked about. And down here in the bottom left is where we, another way, I can click on Power BI, or I can go into, I can always go through this bottom left to whichever experience I'm in. The first thing that we're going to need to do is to set up a workspace. This is kind of a way to organize all of the items that we gather to different areas. We might have a workspace for different groups in our enterprise. We could even have like a cloud workspace versus a dev workspace. Really just an organizational piece. They take a few minutes to create, so I've already got one here. So my personal tenant, my business is called Hyde Consulting. So this is Hyde Fabric. I'm going to go ahead and just create a new Lakehouse. So let's go down to store. You can see we've got a lot of different things that we can do here. But I'm going to go ahead and create Lakehouse. Let's call this. So blank Lakehouse. We've got an area here for tables and for files. Now we don't have any data yet, so let's get some data in. So we've got some links up here. We've got some links here. Let's go ahead and upload a file from my system. And I've got some sales data. Okay, and that was completed. So if I refresh my files area, I should see, yes, here's my CSV that we've uploaded. Okay. Maybe I want to write some queries against this, or I want to incorporate it with other data. So I'm going to move it into a table. So I'm going to So you go back to my files, you'll right click on it here, and we will load to a new table. We'll just call it sales. I think I think this is a comma separated, not tab or anything else. We've got column headers in there. So let's go ahead and load. And this is the piece that hopefully doesn't take too long. Usually this is done in just 10-15 seconds, but I have had some demos where I run into contention and this takes a minute or two. So cross your fingers and say hold your breath, but maybe don't, just in case it takes longer. Okay, we successfully created our table. All right, here's our sales table. Should give us a nice preview of what it looks like the table. But what do we like to do to the tables? We like to write queries against it. So actually, let me show you one thing while I was here. Review files. We can see that here's a Parquet file. And this is about half a meg. When there's a 3 meg file that we loaded in, so we get that 6:1 compression. And here is our little Delta log. And we can look at it and we can see, okay, when did this get loaded? What happened to it? How much data was there? We can see if we go here that it was all an insert from here's our starting sales order number, and there's the ending sales number as well. So this helps us track the data. But we can go ahead and actually write queries against this. So let's back out a little bit. Now we see this note here up the top. It's kind of small to read, but it does tell us that it's a SQL Analytics endpoint for SQL querying and a default Power BI semantic model for reporting were created with this item. Well, let's hop out to our back to our workspace here. We see here's the Lakehouse we just created. But it comes with this SQL Analytics endpoint. So what this is a way to basically exposes a SQL engine to that data to a SQL Lake engine. And we have a semantic model that we can do Power BI reports on. So let's go in and write some queries. And you can see here the perfect. All right, so what this has done, now think about like how many times, if you're an IT professional, how many times has a business user come to you with a file that they need to get loaded into a data warehouse somewhere, or a file that they need to get mixed in with their other data. And now we've actually made this so that it's really easy for somebody to put data into our OneLake and query it, or we can join this to other data here or in Power BI. It allows what Microsoft calls their citizen developers to do some of those things. Our super user business analysts, they don't need to wait 2 weeks for this to go through a rigid IT process of putting in a new file into a data warehouse that no one's happy with because it gets in the way of what the data warehouse folks were going to do next in building, and the business user wanted to report right away. Essentially puts some of the power back in their hands. So that's kind of very easy intro to Lakehouse. One other thing that I want to say. So today, like let's say we're using Databricks. If we're storing data in Databricks, yes, it's in a Delta table, but somebody's having to write Python code in a notebook to ingest data and put it in the table. Here we did all that to get into the table just with right clicking of the mouse. So it really kind of democratizes that first step of ingesting data, getting data into our analytics system. So that was Lakehouse. So we talked about next is our data warehouse experience. This is like the old Synapse simplest, but it's a more traditional data warehousing experience. We're going to put just structured data in here. So usually in a star schema relationship, i.e. facts and dimensions. So the facts would be data like sales orders, and the dimensions are the things you slice and dice by. So who was the customer, when was it ordered, what was the part, what item ordered, etc., etc. And we're developing this primarily with T-SQL. Yeah, so if your shop is used to T-SQL development, great, you already know how to do Synapse Data Warehouse. But even though you're doing T-SQL, it's still Delta Parquet behind the scenes. All right, so let's take a look at the data warehouse. So let's go back to our workspace here. And let's go ahead and create a warehouse. So again, we're going to the store data. Alright, so it's taking a few seconds here to get the warehouse set up. Okay, again, we've got some ways to easily get data into our warehouse, but the main way we're going to do this for purposes of the demo, we move my over here. There's just using regular T-SQL. So I'm going to create a schema for my dimensions. I'm going to create a schema for my facts. All right, and then I've got, we'll just jump straight to the big script here. Now this is about, I think, 4 different tables that I'm creating. Just a series of, if the table already exists, drop it, then create it, and then insert a bunch of sample data into it. So let's go ahead and I probably should kick off the run first. Because this is going to take about usually 35 seconds to get everything in here. So this would be a good time for another question if anyone's got one. Otherwise, just cross our fingers that we do hit the 35-second mark and then it doesn't go, oh wow, 21 seconds. That is a record for this demo. So we see we've got our schemas created. We have our 3 dimension tables. We have our fact table. Awesome. And let's add another SQL preview. Let's see if I've got one still saved here. No, I do not. But anyway, we can very easily run a select to join our order table here to the different dimension tables and say put a simple group by on all the SQL that you're used to using. Everything works. All the joins work. This is everything you're used to doing. Now, one other thing that is nice. Let us pop out. Let's pop back to our warehouse. We're going to go to our workspace here. You see down at the bottom, here's our warehouse that we've created. We have that semantic model again. We don't have a SQL endpoint because the warehouse itself is a SQL endpoint, right? We're always only writing SQL against it, so it doesn't need a separate SQL endpoint on top of it. And if I click on the semantic model, let's go in here. Okay, it's not giving me where I'm hoping to get to. So let's go into the warehouse. Let's go to model layouts. Let's see first of all. So this is the fun thing about Fabric is it's still in flux and things change from day to day. So let me go back to my workspace. Where is the that's what I'm looking for. Want to manage that default semantic model that's been created. So I just checked everything I want everything to be in there.
So Chris, in the Explorer, under the schema, we do see the DBOs, and I think you created the original sales table in the DBO. Do we still see tables that are created from the Lakehouse as well as data that are created within the warehouse, or are they separate?
They are separate. Now, what we can do though is, even though they're separate, is that if I have a new query, I can actually let's.
So you can still query it, I guess, is what you're trying to show here, right?
Yeah, I can query it using a three-part naming convention. So I could actually join my Lakehouse data and my warehouse data together because I've got that single workspace. Yeah.
Yeah, they are in the same. You're right. Yeah.
I was expecting that to. This. All right, so let's just back it up here. And let's see if I can create a report against that. Right, so it's already got my tables available in a Power BI report, basically. And what I wanted to show was opening the data model and just making the relationships. And then boom, it's available in Power BI. But for some reason, I'm not seeing where that is today. But so this is again very simple. To go from an empty data warehouse straight to a Power BI report is very, very quick. let's jump back. So this is the question that always comes up. Should I do a Lakehouse? Should I do a warehouse? So some of the considerations are, if I've got both structured and structured data, I'm probably using a Lakehouse. If I've got only structured data, then maybe the warehouse is a good choice. If my team is using Apache Spark, PySpark, Scala, Spark SQL already, that's kind of a Lakehouse thing. If my team is all T-SQL developers, well, the warehouse is probably still, that's the easiest place to start. If I've got highly complex data structures and transformation, like intricate JSON blobs, okay, it's probably a Lakehouse thing. But I've got that denormalized tabular data columns, that's a warehouse thing. And if my team is data scientists and data engineers, probably Lakehouse. If my team is SQL developers and analysts, that's probably a warehouse thing. There's a link here to a great video from Simon at Advanced Analytics, where he spent like 20 minutes breaking all this down. Now he's definitely biased and fairly Lakehouse, I'd say, but it's a really good, it's a really good video to go watch and to kind of think about all the different pros and cons of each. And of course, P-Stuff has a slide about that. But the actual answer is it's not a one or the other situation. What we're seeing is fairly common is that we talked about the different layers and the medallion architecture. So I've got a client right now that their bronze layer and their silver layer, those are both Lakehouses. But all the T-SQL transformations that they're using, those are being done in a warehouse. And that gold layer is being exposed as a SQL warehouse. And then there, semantic model reports off that warehouse. So that's fairly common. So it's definitely not a one or the other type of situation. Now here's one that I don't have time to show, but this is our data science experience. So if you're using ML Studio today, all the features there that you're looking for, like your notebooks to train the models, then you set up the experiments to evaluate the models, and then like the model that wins, you can store that in the workplace, the workspace, to be used along with your other tools. Real-time analytics, so it's their end-to-end streaming solution. Sorry, this has been renamed real-time intelligence since I built this slide. But it's optimized for time series analysis, so where you're looking at how did the pressure from this one sensor, how did that change over time, right? And you've got just thousands, hundreds of thousands, millions of these little sensor readings coming in all the time. So you're looking at discrete windows, right, based on time. That's exactly what this is good for. Now, right now, you have to use custom, you have to use KQL to query this piece, even though it's definitely Parquet under the covers like everything else. The actual engine they've built to write queries against it is KQL only. So you may have to learn KQL a little bit if you're using the real-time data. But that's okay. It's not too difficult to learn. And then we've got Power BI. So let's go to the next slide here and we'll come back, because this is something that is very exciting. This big yellow line called direct link mode. So Power BI traditionally has always worked in one of the two modes above. So it has direct query. So you set up your model to go back to the underlying data sources. And that's great. You've got real-time data, but it can be slow. Because it's very reliant on how the queries are going to perform, say, against the SQL database you're going back to. So most people usually set it up to do import mode. They bring in all the data into the very back engine, and you refresh that, I don't know, once a day is pretty common, right? So, the very packed engine is super fast, because it actually uses, a column store storage like Parquet does, so it's super fast. But again, your data is a little bit out of date, because it's only as up to date as the last refresh. Now, what we've got available in Power BI and Fabric is this direct link mode. That it goes back to the original Delta tables, and you see here in the slide, it is skipping. Oops. The Power BI is going straight to the tables. It's not going through a SQL endpoint or through a warehouse to get that. So it can be super, super fast. This Power BI reads those tables because, again, they're already in column store, shaped just like Vertipack. So if you design your tables correctly, you can query, terabytes of data in Power BI real time, just as quick as you were querying, import mode previously. So that's great. Let's go look at those limitations. Okay, it's a pretty long bullet point list. Right. But those are actually, they all make sense when you understand kind of how it works. Right. There's no calculated columns and calculated tables. Is a big one. There's a few, size limitations. You can't go against a view, for example, because if we look at the diagram, we're not going through the engine. We're not going through anything that sits on top of those Delta tables. We're going straight back to those Delta Parquet tables. So, putting a view in here would give us the same kind of slow performance that direct query does here. Also, there's a limitation right now still. We can't combine tables from different places. Maybe that will change, maybe not. I think that goes to how things are stored under the, really under the covers. But you can't, if your semantic model is built against a Lakehouse and a warehouse at the same time, it's going to fall back to that direct query, which isn't necessarily slow, but it's just like issuing a brand new query. This direct link can be super powerful. Like I said, you can query terabytes of data at real time. In the speed that you're used to querying a fully refreshed model. So super cool stuff. But some design limitations if you really want to use that. All right. I think I've been going for probably about my hour already. So I'm going to skip the Power BI demo. I think, we still want that, once everything's in the model, it's just available on the right hand side of, Power BI, same as we're already used to using. So here's the big question when it comes to Fabric licensing. And a nice slide again from free stuff. It's kind of buried one of the leads here, which is the top left, and I see it's cut off a bit. We've got a free 60 days trial. Everyone has access to this. If you're able to use an account in Microsoft that has its own tenant, or your work, you use your work tenant, you can set a free 60-day trial. And so far, they keep resetting this. This has been going on for more than a year that you can set like a free trial to try all this stuff out. But so what does it actually cost? They sell it as capacity units from 2 to 2048. And a capacity unit, it's not quite equivalent to a core. But at some level, think of that as a, I think 2 would be like a fraction of a core. And then the cost is your number of capacity units times the rate. And this rate can vary from region to region, but most of the US rates are about 18 cents per CU per hour. So if you set up an F2, it costs less than $9 a day. And then you're paying on top of that for storage, which is $23 a terabyte a month for most US regions. So you can set this up pretty quickly. Now, of course, if your data is going across different regions, you're going to have those however transfer charges that you get today as well.
So you have that for infrastructure plus users, right?
So users are mainly free unless they're using Power BI Pro.
Okay.
In which case you still have, as you can see on the right, they still need to. If you have like a shared report that you published, they still need that Power BI Pro to connect to it. So you're still paying the $10 a month for that pro license on top of that. Now, here's the nice thing about this, is this capacity unit that you're buying, you're not buying your peak capacity, you're buying your average capacity, because they will smooth things out. So, like if I'm buying an on-premises server, my server has to be powerful enough to run all my ETL and ELT, like in my down period, right? Like my overnight processing window. Right, so you have a server that's powerful enough to process all my data into my data warehouse in an hour or 2 hours, right? And then that big beefy CPU that I bought just kind of sits idle the rest of the time and not really being taxed. People will run queries occasionally, but it's not really taxing it the same way that those data transformations do. So what they've done with Fabric is they've got something called smoothing and bursting. That you may have two CUs as your that's your base. You have a workload that needs to shoot up to like 12 CUs to run. It's going to do that, and it's been back down to 2 when it's done. Now, as long as you don't go over your average of two capacity for the day, and it does that average in 24-hour increments. As long as you do the average there, you're perfectly fine. So you're sizing here for your average workload, not your peak workload, which can be a lot cheaper. One thing I should say, everyone's talking Copilot. You need an F64 license in Fabric to get the Copilot features, which becomes much more expensive. I think we're looking at about $6,000 a month if my math is right there. So if your C-suite has been drinking the Copilot Kool-Aid, you're going to need an F64 or above to do that. And the Fabric, this is something that's caused some confusion. The Copilot in Fabric is different than your Copilot in M365 or Office. So if you've got that for your Office, you don't necessarily have it for Fabric. That's something that's caused confusion to a couple of my clients. I've seen people do really cool Copilot demos where it basically does 90% of all the data engineering code for you. Creates your Python notebooks, creates your T-SQL transformations. If used correctly, Copilot can really speed up the development process there. But as I said, limited to F64 and above. So that's it. I'm leaving you a couple of slides and resources. Again, this top one here, this is where the slide deck is uploaded to. So if you've missed any of the links as we were going through, just go download the slide deck and everything's in there. We have a nice intro video here. Microsoft has really gone off this third link. Here's the link to Microsoft Learn. They've really stepped up their game in regards to learning materials and tutorials. In the past, the tutorials, I would say, were kind of lackluster, but now they're a lot more real world, more useful in the tutorials. And then you're going to want to keep following this fabric roadmap to follow up with what new features are coming. If there are some gaps, like in warehouse today, we don't have temp tables yet. That should be coming this quarter. You can keep up with all that stuff at the fabric roadmap piece. And they've got a series, this fabric webinar series. That's a great place to go if you want to see demos on the pieces that I couldn't get to, like the real-time intelligence or the machine learning piece. They've got video demos up there. And then the second link, this is the famous Guy in a Cube playlist. So Guy in a Cube, if you don't know them, two fellows from Microsoft who are really entertaining, really good educators. They put out a lot of historically Power BI content, but now the Power BI is sort of in the fabric fold. There's a lot of content in all the different fabric experiences. So let's link to the playlist of all their fabric videos. If you want to take the next step into kind of diving into fabric, I definitely recommend that's your next stop is that video playlist. Right.
Yeah, thanks.
So that is pretty much it for me. Let me go back to the resources here. And let's see if I can just drop this link to the deck in the chat.
Did we have
We have to stop sharing to put it in the chat here. So that's got all the other links that you might need. And with that, if there are any other questions, let me know.
Do we have any questions here in the house?
You get this presentation slides?
Yeah, the slides will be presented and it's in the chat as well. So we can send that out to the meetup group. So you have all the resources. So Chris, thank you. But it looks
like we've got a question maybe from Sunday.
oh,
Yeah, Chris, thanks for this demo. I'm just curious about your client, about capacity units. Are they facing any issues, especially between the data engineering and the reporting side? Because right now you cannot prioritize the consumption, the capacity units consumption based on which component you're using. So are you facing any issues right now?
No, most of my clients though are on the small, medium business end rather than the giant organizations. So I'm not seeing issues. I have heard of some people that it takes them a little while to dial into what their capacity really needs to be. But there is, if you Google fabric bursting and smoothing, there's a lot of info about that, how that really works, and about how much, I get an F64, what am I scaling up to during those high workloads, and how it's getting calculated.
Good, thank you.
Welcome.
I was wondering about the managing of all the objects that get uploaded into the Lakehouse and the warehouse. Any tips or tricks on how to keep keep that pruned and trimmed?
Yeah, so a couple of things. One thing that they have added, it's still in preview. You may have seen it when I created the Lakehouse. There was an option to check to use Lakehouse schemas. So I would definitely recommend that you do that. And that allows the same schema organization that you're used to in a warehouse in there. What I would suggest too is like if you've got sort of an automated feed coming in that you structure it in a hierarchical folder structure. So maybe you've got a hierarchy that is client, and then maybe year, month, day, and then all the files. Or maybe it's client, specific file, year, month, day, and have a hierarchical structure down to your folders. That really helps, and that actually enables. If you structure it nicely, it enables like Python notebooks to just basically iterate through the whole folder. So that's a really great organizational tool. And then just use security to make sure that like those heavily structured areas for like scheduled files, they're off limits to people to write to. It's just the automated processes that can write to those. And so then you've just got a couple of spaces that it's easier to keep track of. What people are uploading and and then just make sure to also if you can, depending on your like if you're the type of IT shop that bills back internally, great, set up a different workspace for each group or a different folder structure, but definitely a workspace you can get in your bill like a summary of how much was the storage in each workspace.
So you could have an area for marketing, and then Jesse can upload all their spreadsheets and get lost with 400 copies of sales, but not mess everything up for everybody else. And you can bill back their 400 copies of the same sales spreadsheet.
And even if you're not billing back, you can take your invoice to the marketing department and say, hey, your storage costs here, 10 times everybody else's storage costs.
And if you put in just a few more, we can get
really need to, you put an actual dollar amount on it and say, hey, do you really need all of the files, and push some of that work, back to them.
Nice.
But $23 to terabyte a month is you can fit a lot of data pretty cheaply.
Yeah. Excellent. Well, thank you again.
All right. Yeah. Thank you for having me. Thank you for letting me talk your ears off this afternoon.
I've got a much better understanding of what Fabric is and why I'd want to invest some time looking into it.
Perfect. That's the goal. You're the one person that if I always say if I can reach or teach one person in a session, it's been worthwhile. So already it was worthwhile. That's good to hear.
Well, thank you.
Thank you.
Thank you so much.
Yeah. Thanks everybody. Stay warm and go Stars.